Today we will discuss about spectrophotometer. Introduction about spectrophotometer. Compounds absorbs light radiation of specific wavelength. You know, compounds absorb light radiation of a specific wavelength. The light absorbed by the sample is directly proportional to the concentration of sample in the solution. You learned it in colorimeter. The colorimeter is same principle. The light absorbed by the sample is directly proportional to the concentration of sample in the solution. As concentration increases, absorption also increases exponentially. Okay. This is the graph showing absorption and concentration of the solution. As the concentration of the solution increases, the absorption also increases. Okay. This spectrophotometry is actually a modified version of the colorimeter. This is a method in which the absorption or transmission properties of a material is quantitatively measured as a function of wavelength. The basic principle behind this method is that each compound absorbs or transmits light over a certain range of wavelength. The spectrophotometer can be classified into two different types: single beam spectrophotometer and double beam spectrophotometer. In single beam spectrometer, first we have to take the reading of sample, then remove the sample, again put the reference and take the reading. In such a way we have to remove and put the different things in different time. To measure the intensity of the incident light, and sample must be removed so that the reference can be placed each time. This type of spectrometer is usually less expensive and less complicated. Okay. The double beam spectrometer, in this type, before it reaches the sample, the light source is split into two separate beams. From these, one passes through the sample and second one is used for reference. This gives an advantage because the reference reading and sample reading can take place at the same time. You can see the diagram. Light source is there, scanning monochromator. This monochromator make the light into monochromatic light. Then it is split into two. One pass through sample of cuvette and one pass through reference cuvette. Then detector will detect it and display reading will show in the display. Okay. Based on the wavelength of light used, it can be classified into, the colorimeter. In colorimeter we can use only the visible spectra. This spectrophotometer can use UV spectra, IR spectra, etc. Visible spectrometer uses visible range, that is 400 to 700 nanometer of electromagnetic radiation spectrum. Visible spectrometers vary in accuracy. Plastic and glass cuvettes can be used for visible light spectroscopy. Okay. In UV spectrometer uses light over UV rays, that is 180 to 400 nanometer. UV spectroscopy is used for fluids and even solids. Cuvettes only made of quartz are used for placing the samples. In IR spectrophotometer uses light of over infrared range, that is 700 to 15,000 of electromagnetic radiation spectra. The spectrometer consists of the following parts, same as that of the colorimeter. So first there will be a light source. It produces desired range of wavelength of light. Then there will be a collimator, transmit a straight beam of light like that of lens. You have seen in the colorimeter there was a lens after light source, right, to make it parallel. Then monochromator split the light into component wavelength. Okay, we have to make it monochromatic light, right? Then wavelength selector transmit only the desired wavelength. This principle is same as that of colorimeter, Beer-Lambert's law. It states that the absorbance of light by a material in a solution is directly proportional to its concentration in that solution. A is equal to epsilon LC, where A is absorbance, epsilon is denoted as molar absorptivity is denoted as epsilon, then L is the length of solution and C is the concentration. Standardization graph. Standard, that is solution of non-concentration. Solution of non-concentration is known as standards of the compound of interest are made, treated, and their absorbance and concentration values are used to create a standardization graph. This is the standard curve, right? In laboratory, we use this standard curve to know the concentration of the desired solution. That is, either it is glucose solution, urea solution. We will use this standard curve as reference. Okay. So we will learn about standard curve in your practical classes. Just now you just know standard curve is used for the measurement of concentration of solution of glucose, urea, etc. What are the applications of spectrophotometer? First, concentration measurements. Two, detection of impurities. Chemical kinetics, detection of functional group, and molecular weight determination. Thank you.